6.5 is about circular functions. There's really nothing new here. We've been talking, as long as we've been talking about trig functions, we've been talking about cyclical functions or circular functions. Today, the only difference is that now you're going to work with these graphs in radians instead of degrees. All right, so circular functions are trig functions in radians or degrees. So when you think about cyclical, think about, tides or the sun rising or setting, a Ferris wheel. All of those things are cyclical. Okay, and there's a million more examples, and we'll get into more of those as we do them. When we talk about degrees, the Greek letters represent degrees. We use Greek letters. So for example, like sine of theta. When we talk about radians, they're going to just use variables, okay? So they're going to use what we're used to, which is like using the Roman letters. So for example, sine of x. Not that it's a big difference, and they'll usually tell you whether they want it in radians or degrees, or it'll be really obvious because there won't be a degree symbol anywhere, okay? Okay, so everything that we're talking about, every time we're talking about trig functions, we're thinking about things that can be represented going around a circle. Okay, so think about, the circle of the calendar, right? So you start with day 1, let's say January. Okay, the sun rises at a certain time, which is, relatively late, and the sun sets relatively early. When you get to July, though, the sun rises pretty early and sets pretty late, so you have those longer cycles. So, but it's cyclical, right? Because you're going to come right back to January and have a very similar sunrise and sunset. So we'll get into more examples, like I said. So let's go ahead and do example 1. We're going to plot y equals 4 cosine 5x on your grapher. Then you're going to find the period graphically and algebraically. Okay, so I'm going to go to my graphing calculator, go to y equals, I'm going to plot 4 cosine of 5x, and I'm going to graph that. I have a standard window here. This is not very helpful for me. What the heck is going on? So standard window has positive 10, negative 10 on all the axes. Okay, so this isn't going to help me very much. So I would say before I even plot this, I should think about the period algebraically. So remember, it was y equals c plus a cosine of b. Instead of theta now, I'll use x because we're talking about radians. Minus your displacement. Okay, so when I look at this, I don't see my midline being adjusted at all, which is pretty obvious. My midline on this grapher here shows it to be the x-axis. Okay, my amplitude is going to be 4. Not that I necessarily need to know that. And then my b is 5. And I don't have any displacement happening horizontally. So when we were dealing with degrees, we could figure out our period as being 360 degrees divided by b. Well, in radians, we're not going to use degrees. Instead of that, we're going to use 2 pi. So let's figure out what my period's going to be here. if I use 2 pi, oops, why did I do that? Sorry. 2 pi, and I'll divide that by 5. So I get approximately 1.257. So I do 1 period and 1.26 approximately radians. So having my x-axis go from positive 10 radians to negative 10 radians, that's way too much. I don't need to do that. Okay, so instead what I'll do is I'll set my window so it's a little bit more representative. So why don't I go, how about from negative 1.3, and how about I'll go positive 2.6. Let's see what that does. And then let's think about our amplitude. We're going up 4, down 4, so I can even zoom in on that a little bit. Maybe I'll do, how about negative 5 to positive 5. Let's see what that looks like. Oh, okay, I can make a little better sense out of this, I think. Okay, so on my grapher, you know, when I'm thinking about this graph, I want a couple of points here. So right now it looks to me like my high point is pretty much, let's see, I'll call that 4 and negative 4. Looks to me like my high point is right on my y-axis, but we'll double check that. And then it appears to look something like I go down, right? So I'm on the midline, low point, back to the midline, back up to the high point. I'll do one more of those. I'd say my graph looks something like that. So graphically, on the grapher, let's check and see. So one period is going to go basically from this first high point to the next high point. And let's see if they are, in fact, where I think they are. Okay? So I'm thinking to myself, the period should be about 1.257, meaning that this point right here should be about 1.257 if this point right here starts at 0. Okay? We'll call this x and y. So I'm just going to do some, I can trace with my trace. I can also do some calculations to be more specific. I'll go ahead and do that. So I'm going to calculate my maximums here. So let's see, where am I? This is on the left side, the right side, and then I'm going to make a best guess. Okay, so that's about 6.67 times 10 to the negative 7, which basically means I need to move my decimal place back 7 spaces. That's a pretty freaking small number, so I'm going to say that that is 0. Okay, close enough to 0. All right, and then let's go ahead and find our other high point. Oops, why am I doing that? I don't need to move anything until I get my second trace going. Okay, so I'm on the left. Oops, what did I just do? I just messed up. Let me try that again. So, let me change my window. This is what happens sometimes. I apologize. You can fast forward if you want. Alright, here we go. So, I'm on the left side. Oops, whoa. Whoa, this calculator has a mind of its own. Let's try being on the left side. Okay. I'm on the right side now. And then I'm going to my best guess. So approximately 1.2566, just like we had. And so I can say that a period is happening approximately 1.257. Okay, so two ways of looking at that. Pretty simple. Hopefully that was totally review for you. Nothing new. Okay. All right, next, I gave you a handout with the second example so we didn't have to write too much. Let's see, I have to find it. Here it is. Notice that these are not in degrees, they're in radians, okay? So it looks to me like my x-axis is going by units of 1 radian, and same with my y-axis. We're going to find a particular equation for the sinusoid function graphed in this figure, and notice that the horizontal axis is labeled x, not theta, indicating that the angle is measured in radians. And confirm your answer by plotting the equation on your graphic. Okay. So once again, we care about the equation c plus a. I'm going to use the cosine graph. Looks like your book does as well. And the reason I'm using the cosine graph is it's going to be a lot easier for me to go from high point to high point than it is for me to think about, okay, where's this midline? Okay, let me think about going from this midline back over to here. Okay, it's just easier a lot of times, especially when your high points are right on an exact value as they appear to be. So, okay, speaking about that midline, that's going to be my vertical translation. So a couple ways I can think about that midline. Basically, it's the average of the highest and the lowest points, right? So 1, 2, 3, 4, 5, and the lowest point is 1. Divide that, let's see, so add that and divide by 2, you're going to get 3. And does that make sense? Is my midline at about 3? Looks like it, right? Okay, so I know that C is going to be 3. My midline is at y equals 3. Okay, so that tells me my C. Now my amplitude is going to be how high above or below does it go? This appears to be reaching 2 above or below. So my amplitude, and really you can also find that by taking the difference between the high and the low and dividing that by 2. Okay, so 5 minus 1 is 4, and divide that by 2, you get 2. So these are things I've gone over in previous notes, and if you're struggling with it, then you might want to write that stuff down again. But again, my amplitude is basically going to be 2. Now to figure out my period, because my B depends on my period, okay? So I need to figure out that my period, let's see, so I'm going from high point to high point. So it looks like my first high point starts at 1, and then this high point is at 11. So it seems to me like it's going a total of 10, right? So my period is 10 radians. Now how does that help me with my B? Well, here, B is going to be 2 pi. When we dealt with degrees, it was 360, but now it's going to be 2 pi divided by my period, which is 10, which is also going to be pi over 5. You can use pi over 5, okay? It's going to be more exact anyways. Which leads me to, do I have a horizontal shift? Well, if I'm thinking about the cosine graph, then I do have a horizontal shift, because my highest point should be my y-intercept, but it's been shifted over 1. So I have a shift. I've moved to the right 1. Okay, so I think that's pretty much it. We're done. It's that easy. That's pretty simple, right? So y equals, my midline was at 3. My amplitude was 2. I used the cosine. Doesn't mean you can't use the sine. You would just have to think about this point. And so then like your horizontal translation, for example, would be, that would be hard, maybe 8.5. See what I'm saying? It's not exact. So it's a little bit harder to do, whereas our high points were exact. Okay. So anyways, my B ended up being pi over 5. X is my input, and then I minus 1 from that. So we really haven't learned anything new, but you do want to be able to do these things in radians, in addition to in degrees, okay? And then if you go ahead and you plug this back in, if you plug this in, it should look just like this. And again, think about your window. So this is going to 10, so you probably want your window to go to about 20 for your x-axis, and then your y-axis appears, maybe like 10.